Today we'll be solving this question, detect cycle in a directed graph. The question goes like, given a directed graph with v vertices numbered from 0 to v minus 1 and e edges, check whether it contains any cycle or not. So we have to basically check if the graph contains a cycle or not. All we need to first identify is what is a valid cycle. Let's see the example one first. We are going with a graph that starts with 0, goes to 1, goes to 2, and goes to 3. This has a cycle because 3 repeats in itself, right? This is a cycle. This arrow in itself is a cycle. So yeah, 3 to 3 is a cycle. Let's see this one. 0, 1, 2. Is there any cycle? No, there is not, because there are no nodes that is getting repeated. So let me take an example that is a little more complicated than what this is. Let's say we have this initial node that starts with 1, go to 2, and we go to 3. And let's say from 2 there is this another node that is coming from that is coming from 4. So is there any cycle in this? We start with 2. Let us traverse this. Okay, how will we traverse this? We'll start with 1, we go to 2, and we go to 3, and there is this disjoint component that is from 4 we are getting 2. This is not a cycle. This is not a cycle even while 2 is getting repeated again. Why so? Because from 2 we go to a point, and from that point we come to 2. Only then is this a cycle, right? This is not the case here. We go from 1 to 2, we go to 3. This path has no cycle, and this is a different path altogether that starts from 4 and then goes to 2, right? So you have to understand this particular case. This question is all about understanding this case in itself. Because see, you are visiting two in, I mean, in two different paths. It is like you are visiting two twice, but both of them are from two different paths. It is not like you are visiting from you are visiting two twice in this path only, or that you are visiting two in this path only. Had this been the situation wherein from 3 you are going back to 2, let's say from 3 you are going back to 2, and yeah, it will be this case. So yeah, in one particular path only you are visiting two twice, right? So this means the graph has cycle, and the cycle, the point of cycle is the node 2, the vertex 2. So that is what the case is. Let's say from 4 we are going to 2, and from 5 also we are going to 2. That won't be a cycle again, because from 5 we go to 2, then that is a different path altogether, right? This is the third path. So this path in itself has two only once. This path in itself has two only once, but this path has two in itself twice. So in this case we can tell that a graph, the given graph is having a cycle. The cycle is at 2. So this is what we have to keep in mind. So how do we, implement this coding wise? We'll have just two vectors, like boolean vectors, wherein we'll store the visited array. In the visited path, visited array, where we'll store the vertices that we are vertex that we are visiting, vertices that we are visiting, and in the path visited array, we'll see if we had already visited this two already in this path or not. Had this been the case that we have visited this path in this already and we are visiting it again, there contains a cycle, else we don't. So from this path, if we go to this path, we'll make sure that we are removing 2 from the path visited array. We'll keep it as visited, of course, because we do not want to DFS traverse it again, but we'll make sure that this being a different path altogether, in itself it is an independent path. So we'll make sure that while switching from this path to this path, we unmark the vertices 2 and all the vertices for that matter, uh, from the path visited array. So that is what our approach will be. Let us go to coding it. This is all about this question actually. This is the case where everyone gets confused when I got it initially, and yeah, let's get into coding it. We are given with the number of vertices v, and we are given with the adjacent array. Adjacency list is what we are given with. So we'll start with making two arrays, bool visited, and we'll initialize this to false. Bool visited of size v, right? Because v is the number of vertices we have, and bool path visited also equal to false. False. Having done that, what we'll do is we'll simply do a DFS traversal from int I is equal to 0, I is less than b plus if not visited, I call a DFS traversal, and DFS of what we'll make, we'll pass this ith, we'll pass this ith what is this vertex, and then we'll pass this visited array, we'll pass this path visited array, and we'll pass this adjacency list that we're given in the question, and we'll do that. But then DFS traversal will return us a boolean value, right? So if the boolean value of DFS traversal is yeah is equal to true, if we are getting a true value, what we'll do is we'll return true. Why are we returning true for that matter? We are returning true because from the DFS traversal, right, this function which I'm going to implement now will get an answer, right? If the condition that I've mentioned, if the array satisfy, if the graph satisfies that condition, that is, it is path visited already, and then we are visiting that node yet again, then it will return true, else it will return false. We'll do that for all the nodes. If no node returns true, it will return false ultimately. This is all the logic. Now it is all about coding the DFS part. We'll code this. This will be boolean, then DFS. What we need a node. right? Node, we need a vector. Okay, we need a bool visited. We'll need a bool path visited, and we'll need a vector in adjacency list. Okay, we've got everything. And now is what will mark this visited of, what do you say, node s2, and path visited of node s2. While returning back, we'll make the path visited, like if we're changing the path, right? Once we change the path, before that we'll have to make this false. And now it is all about coding this. We start for our auto ID at the essential list of what? Essential list of node. If not visited node, I mean ID, it is not visited. You check what? What do you check? You check if the EFS parameter of this node visited, node visited, path visited, and adjacency list. If this is equal to true, return true, and there will be another case when you return true. And when is that? When the node, this condition is for when the node is not visited, right? There can be a case when the node is visited. In that case, we'll have to check if it is path visited. Else, if when it comes to else if, that is when the node is already visited, right? We'll have to check if the node is path visited as well. If path visited of ID, then what do you do? Return true. These are the only two cases when you return true. Else you simply return false, and here also you come back false. Let me compile this and see if this works. Might have a couple of errors. Path visited node will end fire. Okay. Segmentation fault. Crazy. So auto ID in adjacency list, the node that we took. If not visited, call that for partition. The issue is here. Laptop. Pass this new neighbor of it, right? Pass the node itself. This should work. Yeah. Just submit it and see. It works. Yeah, it does. That is all for this video. Meet you in the next one. Thank you.